Hey everybody, this is Mr. Piercy, and in this video what we're going to be looking at is how we're going to use two-column proofs to show or to prove relationships within angles, like linear pairs, vertical pairs, complementary pairs, supplementary pairs, things like that. Taking a look at the first theorem here. Now this is actually misnamed. This is not a theorem. This is the right angles congruence postulate. This is actually Euclid's fourth postulate that he wrote way back in the day. The five basic postulates that he came up with that developed all of the geometry stuff that we know right now. This was the fourth postulate. It's not a theorem. I can accept this as true. But taking a look here, understanding that all right angles are congruent, can we use that information to justify a relationship with some angles? So we have a very kind of basic, straightforward, simple two-column proof in example 1. We are given the fact that we have some segments that are perpendicular to each other, and we want to prove that angle K and angle L are congruent to each other. So like with most two-column proofs, almost every first statement is going to be stuff that's given to you. So when I say angle in step 1, JK is perpendicular to KL and ML is perpendicular to KL, the reason why I'm saying that is because it was given information to me by the problem. Well, if I have these segments here, now I can say that angle K and angle L must be right angles. Because by definition, if I have segments that intersect with each other, I have to have right angles formed. And if I have right angles, then that means angle K must be congruent to angle L because all right angles are congruent. So the right angle congruence postulate. So that was a pretty straightforward example of how we're using a two-column proof to prove a statement about angle relationships. Moving on, we have a couple of new theorems, and these are something that I would say is a proper theorem. It's a statement that I can accept. It's a statement that is true, but I can't just accept it without having somebody explain to me why it's true. And we will be able to prove these things using two-column proofs here. But essentially, if two angles are supplementary to the same angle, then those two angles have to be congruent to each other. Same thing with complementary angles. If I have two angles that are congruent or that are complementary to a third angle, then the original two angles have to be congruent to each other. And that's what we're seeing with our angle measurements here, or with our angle statements here. Now let's take a look at how we're going to use the idea of supplementary angles and some given information to prove, in this case, that the measurement of angle 4 has to be 45 degrees. Well, again, as with most two-column proofs, the first statement that I'm going to have is going to be something that I'm given. So angle 1 and 2 are supplements, angle 1 and angle 4 are supplements. The reason I'm saying that is because it was given to me. Well, if angle 1 is supplementary to both of these, then it means that these have to be congruent to each other. And that's what we're saying here. Angle 2 and angle 4 have to be congruent to each other because they're both supplementary to angle 1. And that's the reason is the congruent supplements theorem. Well, if angle 2 and angle 4 are congruent to each other, then their measurements have to be equal to each other because that's the definition of what congruent angles is. And if angle 2 is equal to angle 45, if angle 2 is equal to 45 degrees, because that was given to me, then I can substitute angle 4 for angle 2 and say that angle 2 is also, or angle 4 is also 45 degrees. And it looks like I have a little typo here. That should say angle 4 right there. Now, taking a look here, I want you guys to go ahead and try pausing the video, answer these questions, but make sure that when it says explain, that you give a complete sentence for your explanation. We can go ahead and pause the video and answer these questions. When you're done, come on back, hit play, and let's compare our work. Okay, hopefully you have some good explanations for what we're talking about here. Going back to example 1, if K is congruent to L, can you use right angle congruency to prove that K and L are right angles? Well, in this case, unfortunately not. you can't prove that these are congruent to each other, or that they're right angles rather, because going back to that postulate, if I were to write that postulate out as a conditional statement, I would say if if I have right angles, then they are congruent to each other. The converse of that would be if I have angles that are congruent, then they're right angles. And that the converse statement is absolutely not true, because simply because I have congruent angles doesn't mean that they have to be 90 degrees. So that statement, unfortunately, is not true. So problem 2, suppose that A and B are complements and A and C are complements. Can B and C be supplements to each other? And unfortunately, in this case, not. If B and C are complements, then they cannot be supplements because their angle measurements simply won't be big enough. Okay, moving on. Here we have a couple of other postulates, linear pairs, or here a linear pair postulate says if I have a linear pair, then their sum is 180 degrees. That might actually be more of a theorem, but I'll take it as a postulate. I accept it as true. And the vertical angles congruence theorem also says that the vertical angles are always congruent to each other. And that's very easily proven, but it's a very basic concept, but it is a theorem because we have to prove that that's true. So moving on, we want to use vertical angles, that relationship, to write a proof showing, in this case, that angle 2 and angle 4 are supplementary angles. Starting off with the proof, angle 4 is a right angle. That was given information to me by the problem. So the next statement is what we got to try and figure out based on the reason that that's the definition of a right angle. Well, the definition of a right angle says something is going to be 90 degrees. So I'm going to say that the measurement of angle 4 has to be 90 degrees. Well, angle 2 is congruent to angle 4 in this case because they're vertical angles to each other. And if I have angles that are congruent to each other, then the measurements of those angles have to be equal to each other by definition. That means that since the measurement of angle 4 is 90, the measurement of angle 2 has to be 90, and that's just substitution. I'm just substituting 90 degrees for the measurement of angle 4 based on what we said in row number 2. So moving on, if we've established that both angles are 90 degrees, so the two angles added together have to be supplementary because they equal 180 degrees. Now, moving on, again, we have a couple of questions here that you guys need to try and answer based on the relationships of the angles that you see. So go ahead and pause the video at this point and find the missing angles in the problems, and when you're ready, hit play again and come back and look at my answers. All right, so let's take a look. Angle 4 is 63 degrees. Find the measurement of 1 and 2. Well, angle 1 and angle 4 form a linear pair, so they're supplementary. And angle 2 and angle 4 form a vertical pair, so they're congruent to each other. Based on that information, I'm going to say 1 and 4 have to add up to be 180, giving me angle 1 to be 117. And angle 2 and angle 4 are the same, so angle 2 is also 63 degrees. Moving on, we're kind of changing up the numbers, but still using the same diagram. Angle 3 is 121 degrees, so angle 3 and angle 1 are vertical pairs. Angle 3 and angle 2 are supplementary. Same thing with angle 3 and angle 4. They're linear pairs. Now the way I worked out this problem is saying that the vertical pairs are congruent to each other and that angle 2 and 3 are supplementary, so angle 2 is 59, while 1 and 4, or 1 is 121 and 4 is 59 also. Next, we're going to take a look at finding some angle measurements based off of the relationships that we have. Now this isn't so much a proof, this is just going back to some angle properties that we know. Early in the geometry curriculum, we've practiced stuff like this in the past, and it's usually when we talk about angle addition postulates at the very beginning of a geometry curriculum, but we're seeing it again here. Recognizing the fact that the angles that we're looking at form a linear pair, FKJ and GKH, they have to have a sum of 180 degrees. So I say that those two angles add up to be 180. In this case, we've already substituted the expressions. What I should really start with is saying that in this case, the measurement, oh, I don't know if we can see the yellow here. Let me pick something bright but a little easier to see. Here I would say the measurement of angle FKJ, or FKG rather, plus the measurement of angle GKH is equal to 180. And then we substitute the expressions, and then we'll combine our like terms and so on. So combining the like terms, the -1 and the +113 gives me 112 to equal 180. Move the 112 over through subtraction. 4x is equal to 68. Divide by 4, x is 17. So now that I know that the measurement of that is 17 degrees, and apparently I forgot to show that this is 17, here substitute 17 for x and simplify the expression, and we get the measurement of angle FKG to be 67 degrees. So here's the last one. Go ahead and pause the video one more time. Find the missing angle for AEB based off of the relationship that you see. And when you're done, come on back and check your work with mine. All right, so hopefully you have a good answer. And let's see what we have. Find the measurement of angle AEB. Well, angle AEB and angle DEC, those are vertical pairs. So vertical pairs are congruent to each other. So that's how I set up the measurements here. The two angles have to be equal in measure, so the expressions are equal to each other. Solving for x, I get 22. Once I know that x is 22, I'm going to go back, substitute it into the expression for angle AEB, and it's going to work out that angle AEB is 70 degrees. Well, that's going to wrap it up for this video. Now, again, the purpose is so that way we can practice writing two-column proofs based off of relationships that we know about angles, whether they're right angles, complementary, supplementary, or vertical pairs. Really doesn't matter as long as we're still using a logical sequence of statements to arrive at the appropriate conclusion that the question is asking us to. But until next time, ladies and gentlemen, thanks for watching and take care.